In this video, I'll explain how to use transactions in a Java EE application. If you've written a basic enterprise Java bean, then you've already used transactions. By default, whenever you call a method on an enterprise Java bean, the application server automatically creates a transaction and associates it with the method call. An example of where this might be helpful is when you write code that uses object relational mapping with JTA. The entity manager in JTA always needs to work with a transaction. So one of the easiest ways to guarantee that there is a transaction is to write your JPA code in an enterprise Java bean. Behind the scenes, EJBs, enterprise Java beans, are using JTA, the Java Transaction API, to manage transactions. You can probably get by without knowing much about JTA. However, it is important to understand transactions, and the JTA can give you precise control over transactions when you're trying to solve performance problems. At the core of JTA is the Transaction Manager. The Transaction Manager is code that is responsible for keeping track of running transactions, managing transactions, and coordinating with other systems involved in a transaction. The Transaction Manager is a sophisticated piece of code that incorporates many sophisticated, low-level coordination and communication capabilities. Your application server will come with a Transaction Manager, and JTA is the interface used to access that Transaction Manager. Fortunately, the JTA specification helps hide the complexity of transaction management. JTA provides high-level interfaces to the services provided by the Transaction Manager. There are three major interfaces: User Transaction, XA Resource, and Transaction Manager. As an application developer, you're most likely to encounter User Transaction. This is the interface you use when you want to obtain more careful control over when a transaction is created. The other two interfaces are much more low level. You would only encounter them if you were building transaction-aware components, like your own JDBC database drivers, or if you're building an application server yourself. So I'm going to focus on User Transaction. There are three main things you need to know: begin, commit, and rollback. Begin is what is used to start a transaction. Anything that happens after you call begin should be transactional. It should comply with the ACID characteristics. Commit tells the Transaction Manager to finish the transaction and save all the changes. Once a commit succeeds, all the effects should be stored durably. If something goes wrong during the commit, then an exception will be thrown and the changes will be undone. Rollback tells the Transaction Manager to cancel the transaction and undo any of the changes. When you call rollback, the database will be returned back to be equivalent to the way it was before you started the transaction. So when we say that a transaction is atomic or all of nothing, this corresponds to either a commit, where everything is saved, or a rollback, where nothing is saved. These three operations correspond to methods on the User Transaction interface of JPA. Here's how you might write them in code. You begin the transaction with begin, then you perform some actions, and these will all be carried out in the same transaction. Then, if everything has succeeded, commit the transaction and all the changes will be saved. Otherwise, if something goes wrong, if an exception is thrown in either operation, then roll back the transaction and all the changes will be reversed or undone. When you make use of User Transaction, you're looking after the transaction yourself. In terms of Enterprise Java Bean, this is referred to as Bean Managed Transaction, because your code, the bean, is managing the transactions. However, Java EE documentation generally recommends against using User Transaction. You should only use it if your application has unusual requirements and you're an expert in using transactions. Instead, container-managed transactions are recommended. A container-managed transaction is a transaction that's managed by the application server. This is said to be declarative because you declare your transaction requirements and then let the system deal with all the details of beginning and committing your transactions. Generally speaking, container-managed transactions produce the most efficient and correct behavior. Now let's look at some code. Here's an enterprise Java bean. It has methods for deposit and withdraw. It is a stateless session bean. By default, session beans use container-managed transactions, so whenever these methods are called, a transaction will be created if one doesn't already exist. What this means is that if there's no current transaction, then just before the method is called, the application server will begin a transaction. When the method returns, the application server will commit the transaction, and if an exception is thrown, the application server will roll back the transaction. We can be more explicit. Even though by default there is container managed transactions, we can say that directly. This annotation declares all the methods on the session bean to be using container managed transactions. By default, every method requires a transaction, but we can explicitly declare that behavior with this annotation that tells the application server that a transaction is required for every method call. So these two annotations are essentially the same as leaving everything with a default. At the moment they do nothing, because this is what you already get if you have no extra annotations. But if you change the parameters, you can configure the transaction behavior. That first annotation, transaction management, tells the container whether to use container managed transactions or bean managed transactions. If you use bean managed transactions, then transactions aren't automatically created for you, and you need to use the user transaction interface to begin, commit, and roll back transactions manually. You can only use this annotation at the top of the class file, and the annotation applies to the whole class. The transaction attribute configures the behavior of container managed transactions. You can use this at the top of the class file, in which case it applies to every method in the class, or you can individually set it to every method in the class. There are 6 possible values. Here are the first 3. These are used when your code needs a transaction to run. Required means that there needs to be a transaction, so the application server should start a new transaction if none already exists. So it prefers to use an existing transaction, but it will start one if it needs to. Requires new means that it will always start a new transaction. If there's no transaction, it will create a transaction. If there is a transaction, it will suspend that current transaction and then start a new transaction. Because this is a separate transaction, it can be committed or rolled back separately from any transaction that might have been running before the method is called. But once the method returns, then that previous transaction will be resumed. Mandatory means that there needs to be a transaction. But if none exists, then the application server will throw an exception. So mandatory can only be called from other code where a transaction has already been started. The next 3 types are for when you have methods that will work without a transaction. Supports means that your code doesn't care whether there's a transaction or not. It works if there's a transaction, it works if there isn't a transaction. Not supported means that the method should run without a transaction. If there's no transaction, then it just runs. If there's already a running transaction, then that running transaction should be ignored. The running transaction gets suspended, and then it's resumed once your method completes. Never is like the opposite of mandatory. The method must run without a transaction. If there is a transaction, then an exception will be thrown. Another way of looking at these transaction type attributes is that you need to ask yourself whether your code should be transactional or not transactional. Then you should decide what should happen if things aren't right. For example, should it fail if you need a transaction but there isn't one? Or should the application server automatically correct the problem? For example, by starting a new transaction if there isn't one? Or should your code just work with whatever it's given, not making any changes to the transactional state of the application? Now, at this point, an obvious question might be, why do we need all of these types? The answer is that we need these types because they cover a range of scenarios that are commonly encountered when you're writing your domain logic. We have all of these transaction attribute types because they're all needed. For example, a deposit or withdrawal clearly need to be in a transaction, so they would need a requires or mandatory annotation. But suppose you also want to record attempted bank transfers. Suppose you want to know if there were any transfers that failed. If you record a transfer attempt in the same transaction as the transfer itself, then if an exception occurs during the transfer, then everything will be rolled back, including that record of the attempted transfer. So you might want to log the attempt information in a separate transaction using requires new or in no transaction at all with not supported. To finish off this discussion of container managed transactions, I'd like to look at rollback of a transaction. It isn't possible to directly roll back a container managed transaction. However, there are two alternatives. I've already mentioned that throwing an exception is one way to get the container to roll back the transaction. If your exception is a runtime exception, or if it extends from EJB exception, it will cause a rollback. You can also write custom exceptions that cause rollback, but to do this, you'll need to add a special annotation to the exception class. The other way to cause a rollback is to inject an EJB context and then call setRollbackOnly. This method will still keep running and finish normally, but this tells the container that it's not allowed to commit the transaction. So once the method completes, then the container will roll back and undo all the changes made. So that's container managed transactions. Bean managed transactions have less to remember, but they are harder to use and harder to get right because you need to manage the transaction yourself. By default, a session bean uses container managed transactions. So that means that if you want to use bean managed transactions on a session bean, you first need to declare that the bean uses bean managed transactions. You can do this by just changing the transaction management attribute. Next, you need to get access to the user transaction interface. You can do this with dependency injection or JNDI lookup. Here, I've used the resource annotation to perform dependency injection. Once you've done that, you can just use the injected user transaction object directly to begin, commit, and roll back transactions. It isn't really a good idea to mix and match with beans with bean managed transactions and container managed transactions. However, it is allowed. Code that uses bean managed transactions can call code that uses container managed transactions, and the one transaction will be used across both. However, if code that uses container managed transactions calls code that uses bean managed transactions, then the container managed transactions will be suspended while the bean managed transaction code is running. So to conclude, the Java Transaction API gives you access to the transaction manager that ensures that your code and all of the databases that you use work together in a single transaction. The best and easiest way to use transactions in Java EE is to create an enterprise Java bean and then use the default option of container managed transactions. By default, your code will run with the required transaction attribute type. However, you can override this default by setting a new attribute for the entire class or apply the annotation to individual methods of your EJB.